Okay, the topic today is complex fractions. You may ask yourself, when will I ever use complex fractions? You won't. You will never make use of them in the real world. Okay? So the question is, why do we learn such things? Well, this is also a pre-calculus course, and you are going to use calculus. In order to do calculus, you have to understand complex fractions. I'll make this clear. You will not be able to do calculus if you're not able to do complex fractions. You just drop the course right away for next year. Unless you can get this. If you can get this, then you're good to go. So let's venture out and see what we got. This is an example of a complex fraction. So let's say x over 3 divided by x squared over 12. Okay, that's an example of a complex fraction. 2 minus 1 over x divided by x minus 1 over 3, complex fraction. Fraction within a fraction. Okay, and we need to learn how to simplify those. Just for the record, this is not considered a complex fraction. That is not something we can reduce, and there's no need to try to work that through. So that's not a complex fraction. So, all right. So the first thing we do is create one fraction in the numerator and denominator. So as we have 1 over a minus, I'll write this as b over 1, divided by 1 over b minus a over 1. What do I need to do in order to create one fraction in the numerator? I have subtraction right now, so what am I going to find? Common denominators. What will the common denominator be? A. So I multiply this side, top and bottom, by a, and then the denominator I'll multiply top and bottom by. And when I do that, I get 1 minus ba over a divided by 1 minus ab over b. Okay. So now I have one fraction in the numerator, I have one fraction in the denominator, and that brings me to my second step. My second step is to multiply by the reciprocal. Another phrase that many teachers use is invert and multiply. Invert means to take the reciprocal and multiply. But we're going to do that here. We'll cross that off and multiply by its reciprocal, which will be b over 1 minus ab. And then our last step is to simplify. Our last step is to simplify. Okay. 1 minus ba and 1 minus ab, are those the same? Why? Multiplication is commutative, so you can rewrite it as the same. But is ab minus 1 the same as that? No, that's definitely not. But these two are the same, so I cross off, I get b divided by a, and that's my answer. Okay. And so those are the steps that you will follow every time for simplifying a complex fraction. Okay. All right. Flip it over, or we go to the bottom one. Joe, you see the stapler behind me? Behind or on the desk? If you want to grab that, if anybody wants to staple this to their previous set of notes, that's fine. Lady, do you have a question? How else would you do it? So you would take 1 over a minus b. Whoop. 1 over a minus b. And what would you multiply it by? That's because, so I understand you, so I'm just trying to make a point. And here is the point. We don't know the reciprocal of that because it's not written as one fraction. That's why we must write as a fraction. Okay? All right, we go to problem 2, okay? what is the common denominator for the top going to be? C times x. So I'll multiply top and bottom there by x, top and bottom by c. And when I do that, what do I have in my topmost numerator? C minus x over cx divided by x minus c over 1. And I always write it as a fraction so we don't get confused about what is a numerator and what is a denominator. Okay? What's my next step? Multiply by the reciprocal, which is 1 over x minus c. C minus x and x minus c, are those the same? They are not. They differ by a factor of -1. So if you were to take a -1 out of the expression x minus c, you'd come up with a positive c and a negative x. So then they would cancel. So here's how I show my work, and this is how I'll understand what you're doing if you choose to do this. Okay? So if I take out a -1 and then cancel them off, I know that you did what you were supposed to do. Does that make sense? Everybody okay with that step? So my final answer is then 1 over negative cx. Or you could put the negative on top. Or you could put the negative right out front. It doesn't matter so long as it's one negative. If you chose to put a negative in the top and the bottom, well, then that's problematic because they would cancel each other out, right? You need one negative. I don't care where it is. Okay, we flip it. Temptation here when people see this problem is to add an h. Well, now we have a 3 plus h in the denominator. But that's entirely illegal, isn't it? It would be like saying I have 1/6 and I'd like to add 2/5 to that. So what I'm going to do is I'm going to add 1 to the top and the bottom. That's totally illegal, isn't it? So therefore, we're not just going to add the h, but rather we're going to multiply by 3 plus h. And the other side will multiply by 3. So therefore, we have 3 minus the quantity. When I say quantity, I mean everything in parentheses. 3 plus h divided by 3 times the quantity, 3 plus h, divided by, what's my lower fraction? H over 1. Sometimes before you multiply by the reciprocal, you'll see something else cancel out. So does something simplify in the numerator here? Yeah, the 3's will go away and I'll be left with negative h because you distribute the negative through. So I have a negative h over 3 times 3 plus h over h over 1. Can I now multiply by the reciprocal? Yeah. And what happens? H is canceled. And I get -1 over 3 times 3 plus h. Now you could write it as 9 plus 3h if you like in the denominator. It doesn't really matter. I like to leave it in that factored form. Okay. Number 4. Yeah. And when you say that, there's almost something inherently wrong about it, right? Because you're like, that can't be right because that just seems like too much work, right? It just seems too much. So the first stage is acceptance, okay? And after we accept, then we persevere. I don't know. There's stages of grief. There's stages of all sorts of things. We should have stages of math problems. So we're going to multiply both sides by that trinomial. I'm sorry, top and bottom by that trinomial. And then on the left-hand side, we'll multiply top and bottom by that binomial. And you know, if there's one thing that I've learned in mathematics, I've learned many things over the years, but one important thing I've learned is that you need to develop trust in the process. If you know that you're using the right process, then you got to learn to trust it, and hopefully something good will work out here. So let's FOIL this out. What do I get? All right. I don't like it, but I'm going to trust. Now I'll distribute a negative a through here. What do I get? And in the denominator, we have a plus 4, a plus h plus 4, all over. Oh. Well, what do you notice? A lot of things cancel out. A squareds are gone. 4a is gone. AH is gone. Multiplied by the reciprocal, and then what else goes away? That h. Well, that's a lot better, isn't it? Kind of crazy how that all cancels like that. It won't be the last time you see a problem like that. There's a lot. This is actually pulled from a calculus problem that you'll revisit later on. Let's go with something that you won't see in calculus as a problem, but this is a good example of a complex fraction again. I've led you through a lot. Why don't you tell me what to do now? Okay, so you're going to make a common denominator here and here. So x plus 2 and x plus 2. Sounds like a great idea, Grace. Does your name mean Grace? Imagine that. Wow. You have a self-evident name. See, nobody ever asks you what your name means. Like, well, it's Grace. So. It means undeserved love, right? There we go. All right. Here we go. So x plus 2 times x minus 5, and we get I'm going to go minus 3x, minus 10, minus 18, over. Nine x. And by now, you've started to realize that if you multiply by the reciprocal, you know, these denominators are going to cancel, right? So that's one good thing, hopefully a pattern that you've seen develop, that these denominators will go away when they're the same. So I'm going to kind of, you know, put a step together here. I'm going to raise x squared minus 3x minus 28 over x plus 2 times x plus 2 over x squared plus 9x plus 20. So you already anticipated the x plus 2's canceled. Somebody else said something intelligent in the back there. Factor. Great idea. X minus 7 and x plus 4. I think I have that factored right. I don't do it that much. X plus 4 and x plus 5. Do I have that correct? So are my those go away. X's are gone. We get negative 7/5. Boom! Just trying to make my point. All right, last example. What do you think I should do? Charlie, what were you going to say? Charlie's got the right idea. Sometimes people want to actually move them to the top and the bottom. You can't do that due to the addition and the subtraction. So that's the numerator. That's the denominator. Okay. Don't look at the problem. Just look at this. 4x to the negative 1. I can rewrite that as 4 over x, correct? That's what I did here. The 4 is not being taken to the negative 1 power. And I can't just drop this x to the denominator because it has the subtraction, the addition in there. It's not written in all as multiplication. So it doesn't just move around. So this part's there, this part's here, and this part's here. All right, we worked through. Hey, we just climbed the mountain of confusion. Way to go. Okay. Which, by the way, this is Mount Meru, and I would highly recommend that you watch the documentary. I saw it on Amazon Prime for free, Meru. I told everybody last year, and nobody watched it except Emma Grossman watched it. She came back this year. She said it was phenomenal. You should watch it. A great documentary. It's a couple. All right. Okay. What's the common denominator in the top? So I have a 4x squared minus 4x plus 1 all over x squared. And in the denominator, the common denominator is x squared as well. So I have 4x squared minus 1 all over x squared. Okay, so last of all, multiply by the reciprocal, x squared over 4x squared minus 1. I see that the x squareds do cancel. And I'm left with 4x squared minus 4x plus 1 over 4x squared minus 1. Can you? Does it? You think? How would you know? Try it, right? You gotta try it. You don't know unless you try, okay? I don't know, let's try it. Negative 2x makes negative 4x. You guys got to understand, if it didn't factor, it would be prime, correct? Well, is the number 19 prime or composite? Prime. Is the number 35 prime or composite? Is number 51 prime or composite? 51 is composite, 17 and 3. So my point is this. If I all of a sudden give you the number 1,253, you really don't know if it's prime or until you start trying to divide it, right? It's the same thing with factoring. You don't really know until you really give it a try and see what you can come up with. So these are gone. 2x minus 1 over 2x plus 1. I have a worksheet for you to work on. You have the rest of the hour to work on it.